for number 3,
and then we bring down
okay.
the -9. So then we need to see what times 6x gives us negative 18x squared. So what would that be?
It'd be negative 3x.
Perfect, negative 3x. So we multiply negative 3x times negative 6x, and we get negative 18x squared. Negative 3x times negative 5, or times 5 would be negative 15x. We need to change the signs here to get them to cancel out. And then we combine. So negative 9x plus 15 would be 6x. Then we bring down the 5.
It's just 1.
So then we multiply the 1 times 6x plus 5. We change the signs here. So both cancel out, and we have no remainder.
Okay.
So this would be our answer.
I get it now.
Perfect. Looking back at, because we did this one for number 2. So our factors of what we were given would be what divides into it evenly, so what we started with. So one of our factors would be x minus 4. And then we also know that this 5x plus 7 goes into it evenly. So our other factor would be 5x plus 7. So this, it just had you write the answer this way as like 2 factors rather than just like writing the answer.
Oh, because I was really confused and I was like trying to plug in like negative 5 over 7 to the whole problem, and it was just like taking me forever.
Yeah, so just remember, if it divides in evenly, it's a factor of the function. So you're welcome. Okay, I want to move on to some of like 2.1 and 2.2, but I'll do another example of synthetic division towards the end. So I'll get another one of synthetic division in. So you could see a problem like this on the quiz where it asks you for domain, range, vertex, axis of symmetry, max or min, X-intercept, and Y-intercept. So for this problem, where should we start? How do we find the domain and range?
You can put in vertex form first, I guess.
We could, but okay, if we start with the vertex, what's that formula that we have that tells us what the vertex is when it's in standard form?
It's the, oh my God.
Anybody?
It's the formula with the B and C. Oh, never mind.
So this tells us what our x value of the vertex is.
Oh, yeah, okay.
And we get our A, B, and C from our coefficients from our function. So we just plug it in. So we have negative 12 on top. And then 2 times, what would our A be here? What is our A? 1. So negative 12 over 2 would be negative 6. So our x value in our vertex is negative 6. How do we find the y value in our vertex?
You just plug in the negative 6 for x.
Perfect. We plug in the negative 6. So we have negative 6 squared plus 12 times negative 6 plus 40. So negative 6 squared would be 36. 12 times negative 6 would be negative 72 plus 40. So this would be 76 minus 72. So we would get 4. So our vertex is negative 6, 4. What would our axis of symmetry be?
x equals -6.
Perfect. We always get our axis of symmetry from our x value and our vertex. So x is equal to -6. Now, how can we tell if we have max or min here? Does this graph open up or open down?
Up.
It opens up because our A is positive. So if it opens up, do we have a maximum point at our vertex or a minimum point?
Minimum.
Minimum. Perfect. So we have a minimum. And what value is our minimum at?
-6.
It's not the x
No,
value.
it's at 0.
Not at 0. If we graph this, right, we have our vertex at -6, 4, and we know that it opens up. So what is our
So it's... Oh, no, no.
what is our minimum value?
4.
4. So we always get our minimum from our y value. So our minimum is 4. So for vertex, axis of symmetry, and max or min, it's always just going to be those two numbers. You repeat the x value for axis of symmetry, you repeat the y value for max or min. So the y value is always your max or min. Now, how do we find our x-intercept? Remember, x-intercept, you plug in 0 for y. So when we plug in 0 for y, we have 0 is equal to x squared plus 12x plus 40. How do we solve this? What do we need to do? We've been doing this since chapter 1.
Now you just factor.
We just factor it. So we need 2 factors of 40 that add up to 12.
Eight times... No.
8 times 4.
8 times 4 is 32. Yeah, I don't think we have any here. So what do we need to do if we don't have 2 numbers that factor in evenly? If we can't find 2 factors right off the bat, what do we need to do?
So you multiply them together.
We would multiply like the first and the last together, but the first is 1, so we only need to do that when our a value is not 1. We use the quadratic formula to find factors. So we have -b plus or minus the square root of b squared minus 4ac over 2a. Everybody remember this?
Yes.
So then we just plug in our a, b, and c. So we have -12 plus or minus the square root. B squared is 144 minus 4 times 1 times 40. Over 2a. So -12 plus or minus 144 minus 40 times 4 would be 160. Over 2 times a, which is 1, so just 2. Okay, so negative 12 plus or minus the square root 144 minus 160 is negative 16 over 2. We can factor out a 4 from our square root of 16. Oh yeah, it's 4 times 4. So this would be negative 12 plus or minus 4i over 2, and then we can divide a 2 from everything. So this would be negative 6 plus or minus 2i. So this would be our x-intercepts, and we write our x-intercept as a point. So this would be negative 6 plus or minus 2i, and it's when our y is 0, so it would just be comma 0.
We won't ever have to graph that, right?
No. If you look here at our graph that we did, does it cross the x-axis? Does our graph? No. So that's why we get an imaginary number, because our graph doesn't cross the x-axis. So you won't have to graph this. How do we find our y-intercept? If we plug in 0.
Putting in 0 for the x's.
Perfect. So x is 0. So when we plug in 0 for our x, we have 0 squared plus.
Just end up as 40.
Yep. So this would be 0, 40. Okay, now back to our domain and range. Now that we have a graph, it's easier to find our domain and range, right? So for domain, we look at our x values. So we start the left and go to the right. What is our smallest x value here?
Would it just be all real numbers?
It would be all real numbers. So we go from negative infinity to infinity. So our domain keeps going forever in the left direction and forever in the right direction. So our domain is all real numbers. Now for our range, we start at the bottom and go up. So where does our graph start at? What point?
4.
At 4.
4. And we put a bracket because we have a closed dot at 4. And then where does our graph end? Infinity. Perfect. So on the quiz, it will ask you for all of this. It won't ask you to graph it, but sometimes it helps to graph to see your domain and range.
At the beginning, and you see an x squared, can you just assume that it's going to be a parabola going up?
Yep. Anytime you see an x squared, if that's your highest variable, your highest exponent for your variable, then it's going to be a parabola.
And then the domain's always going to be all real numbers, right?
Yep.
And if there's a number in front of it, do you still assume that or no?
Yes. Yeah, you would still assume it. The only thing that the number changes, like if you had a number in front of the x, you would just have to plug it into a, and it's a little bit harder to factor, but yeah, it would still be a parabola. All right, one last thing about this one, looking back at the x-intercept, if we see that it does not touch the x-axis, then we would have no x-intercept. So I know I said in class that the I, so if we get an imaginary number, it's because it doesn't touch the x-intercept, but instead of actually doing the quadratic formula and writing it all out, if we know that it doesn't cross the x-axis, the x-intercept would just be none. So here we have no x-intercept. So you wouldn't, if you get an imaginary number, you don't need to write it. You can just say that there is no x-intercept. That asks you for the roots, the end behavior, multiplicity, and if it touches and turns or crosses at the x-axis. So first thing we can do here is find our roots. So what do we need to do to find the roots? Remember, the roots is another way of saying the zeros. So what should we do?
Do you just equal it to 0 and have to factor it out?
Yep, we just set it equal to 0 and factor it out. So how would we factor this?
You could divide the whole equation by 5 just to make it, to simplify it.
Yeah, we could do that. So we would have x to the 4th minus 2x squared minus 1. Because when we divide 0 by 5, that just stays a 0. So now what do we do?
Now you multiply the leading number, or the leading variable, with the end one. So it would be x to the 4th power times -1.
You would only do that if your coefficient out front is not 1. So here it would be 1. For this one, we factor it the same way that we always do. But instead of having an x squared, we have x to the 4th. So that would mean we start our factors with x squared.
Oh, okay.
So we factor it same way as we would before. What are two factors of -1 that add and give us -2?
I don't think there are any.
There are not.
Do you have to do the quadratic formula for that?
Let's make this a
Or is
positive
it
one.
different?
So I'm changing this to a +5.
What would we do if we had the negative, though?
You would have to do the quadratic formula.
Okay.
What are two factors of +1 that add to give us -2?
-1 and -1.
Perfect, -1 and -1. So we plug in -1, -1 to our parentheses. And this is still equal to 0. So we would have x squared minus 1 is equal to 0, and x squared minus 1 is equal to 0. We would just solve for x here, so we add 1 to both sides, so we have x squared is equal to 1, and x squared is equal to 1. We take the square root to get rid of that squared, so x is equal to the square root of 1 would be plus or minus 1. So what would our roots be?
It'd be 1, comma, -1.
It wouldn't be,
Well, I mean, not as a pair, but like,
right, so we would just have 2, so it would be plus or minus 1.
okay.
But we have 2 sets of plus or minus 1, so we would just write it twice. Remember, our highest exponent tells us how many roots we're going to have. So here we need to have 4 numbers for our roots, so we just have 2 positive ones and 2 negative ones. So this highest exponent tells us the number of roots. How would we find our end behavior?
Looking at the first exponent.
Perfect. We look at our first exponent. So when it is a positive and even, what do we know about our end behavior of our graph?
They both go up.
They both go up. So we would say rises left and right. So since it's even, it looks just like a parabola. It ends going up and up. And we know that it's up and up because our leading coefficient is a positive number. Now moving on to multiplicity. Multiplicity, we just need to look at our roots. Do we have any roots that we have multiples of?
Yeah. So we just say 2.
So we would have multiplicity at -1, and we would have multiplicity at +1.
Oh, so you wouldn't just give a number? You just have to
we could say
what the root is?
Multiplicity of 2 for each. Because remember, the multiplicity, when it's an even number of multiplicity, that helps us determine whether we are going to touch and turn or cross the x-axis.
Would this be one of those free response questions?
Yeah.
Or would
The whole quiz is free response. So this brings us to touch and turn or cross the x-axis. We look at multiplicity to tell whether we touch or turn or cross. Touch or turn, we would need even multiplicity. Cross, we would need odd multiplicity. So do we have even multiplicity or odd?
even?
Even. Both of our multiplicity is even. So we would touch and turn. At -1 and 1. So on the quiz, you will see a question like this where it gives you a function. You have to name the roots, the end behavior, multiplicity, and whether it touches and turns or crosses at the x-axis.
Ms. Carver?
Yes. So we would have 5x cubed minus 9x squared minus 13x plus 6. And we need to divide this by, let's just say x plus 2. Whenever we're dividing, we need to make sure that we have all of our exponents present. So whether it is synthetic division or long division, we need to make sure if we start with x cubed, we need to have an x squared, an x, and a constant. So here we have them all, we don't need to add anything. For synthetic division, we need to change our sign of what goes on the outside. So since this is an x plus 2, on the outside we're going to put a minus 2. And then we just write all of our coefficients inside the box. So we have 5 minus 9 minus 13 plus 6. We drop down our 5. Now we multiply what's on the outside. So we have -2 times 5, which would be -10. We add the inside, so -19. Multiply the outsides, so 2 times 19 is 38. Add the insides together, 25. 2 times 25 would be -50. -50 plus 6 would be -44. So what is our remainder here?
-44.
-44. This one's our remainder. What would our answer be?
5 squared minus 19x plus 25 plus -44 over x plus 2.
Yeah, we could say minus 44 over x plus 2. Perfect. So since we started with x cubed, our answer is just going to have one less x than that. So our answer starts with x squared. Awesome. Good job, Olivia.